Welcome to Akshar online classes. This is Gafar sir, the physics faculty. Let's start our session. Yeah, shall I start the session? Yeah, in the last class I completed about pressure and its formula, and what is the what is the application of the pressures I have discussed, isn't it? Now today we'll discuss types of pressure and expression for pressure exerted by the liquid. These two concepts we'll discuss. Understand? And we will give some example problems also. Yeah, first of all, types of pressure. Already in the last class I explained about pressure and its formula. So pressure P is equal to, tell me what is the formula for pressure? Thrust force acting per unit area. Thrust force acting per unit area, and its formula, units are Newton per meter square or Pascal. And next, in CGS system, can you tell me what is the formula for, what is the unit for CGS system? The CGS system is dyne per centimeter square. Dyne per centimeter square is a CGS unit. Newton per meter square is a SI unit, or Pascal also we can call. And this is all about what? Pressure formula. And now types of pressure. First one is upward pressure. Upward pressure. Upward pressure. How we can experience this upward pressure in our daily life? So let us assume that take a container. This is a container. This is a container. In this container you can take a liquid. This is a liquid. When this is a liquid, this is a liquid. When this is a liquid, in this liquid keep a ball. Keep a ball and keep a plastic ball and press it. After pressing, just leave it the ball. Remove your hand. What happens? In which direction the ball will move? Guess in which direction? Upward it is moving. The ball will move upward direction. Why this ball is moving upward direction? See here, when it is submerged in a liquid, the liquid is applying some pressure on this ball, so the ball is moving upward direction. So the name of the force, in which direction the ball and in which direction the pressure is acting. The pressure is acting in which direction? Upward direction, so that the ball is moving. This upward direction pressure also called, due to this upward pressure, some force will be existed. That force is known as buoyant force. What is the force here? Buoyant force. Buoyant force. Buoyant force is a force because of the upward pressure acting on the bodies when it is submerged in a liquid. Understand? So this is all about what? Pressure, upward pressure. And similar way, downward pressure. One more word. Downward pressure. Downward pressure. And the same thing. Let me take here, I'll take a container. In this container, I'll take a liquid. So this is a liquid, completely liquid. It's totally liquid. In this liquid, the liquid has a bottom surface and it has a mass. The liquid has a mass m, and the liquid container having bottom surface. Now, when the container having bottom surface, this bottom surface of the container bottom will experience a pressure due to this liquid. This, whatever the pressure exerted by the liquid on the bottom surface is in which direction? Is in which direction? Downward direction. So that kind of pressure is known as what? That kind of pressure is known as downward pressure. Understand? The next similar way, one more pressure also there, pressure type lateral pressure. One more type of pressure we have, that is lateral pressure. Lateral pressure. What is this lateral pressure? Again, take a container. Take a container. Let us assume that this is a container. In this container, you pour some water. No water. Pouring some water. Now, when pouring some water, now keep a small orifice. Keep some small orifice and keep some small hole for the container. Then what going to be happen? From the container, liquid will spill out. Liquid will releases. But liquid, when the liquid is releases, it is move. I mean, it is cover some range. When you are keeping small orifice, the liquid is not leaking this way. The liquid is not leaking as it is downward direction, but it is having there somewhere it is hitting the ground. Why they are not hitting the ground at the same of the bottom of the container? It is not hitting the bottom of the container. The liquid is releases hitting the some distance from the container. Why this so? Because this liquid also having some pressure acting on the lateral surfaces. Due to that pressure, the liquid is hitting to somewhere else from the container. This is because of pressure. Pressure, what kind of pressure? Lateral pressure. So simply we can say lateral pressure is nothing but pressure exerted by the liquid on the sides of the container. On the sides of the container. That is known as a lateral pressure. So pressure exerted by the liquid on the bottom of the container is what? Downward pressure. Pressure exerted by the liquid upward direction is known as upward pressure. So these all the things are nothing but different types of the pressures. Understand? Take down. And the next one is pressure exerted by the liquid. Formula for pressure exerted by liquid. Formula for pressure exerted by the liquid. See, now let us take a container. Understand? The container. Before having okay. Let us take a container. In this container, let me take liquid. Let us take a liquid. This totally liquid. Liquid. This is a liquid. When this is a liquid, understand? Now this liquid having mass here. The liquid has mass here. Understand? This mass has some weight together. The weight is acting at where the total weight is acting on the bottom surface of the container. So when total weight is acting on bottom surface of the container, it will exert some pressure. So from your general formula for pressure, what is the general formula for pressure? Perpendicular force per unit area. The area of the container is A, bottom area of the container is A, and this height of the liquid column is, you can take as H. Height of the liquid is, height occupied the liquid is H, area of the bottom surface is A, then from here pressure is equal to, so here the thrust force is nothing but weight of the liquid, The weight of the liquid I can write as a mg by area. But as you see this mass you can write as density into volume. Actually, in the previous class when I explaining about gravitation, I given some density formulas. Different types of density, areal density, volume density, next linear density, the formulas I have given, isn't it? So here, what is the density? Volume density is equal to total mass by total volume. Am I right? From here, from this formula, total mass is equal to density into volume. So this formula you can apply here. Pressure is equal to density into volume into G by area. But observe that you can write this volume as, this volume is nothing but volume of the liquid. The volume of the liquid you can write as the area of the container, and height of the liquid will give the volume. Then pressure is equal to height into area, area into density into G by area. The area gets cancelled. The remaining thing is pressure is equal to H rho G. So this is the formula for pressure. When this is a formula for pressure, in this case, H representing the height or depth of the liquid column. Understand? Next, rho means density of the liquid. What is rho here? Density of the liquid, density of the liquid, and G is acceleration due to gravity. Acceleration due to gravity. So this is your formula, very important formula. Okay. So this H rho G, pressure is equal to H rho G. Tell me, this pressure is only exerted by what? This pressure is only exerted by this liquid. This liquid on where? On the bottom surface of the container. Pressure is exerted by the liquid on the bottom surface of the container. Understand?
So what E represents H?
Here, this is not E, this is rho. Density. Rho. H rho G. H means height or depth of the liquid column. Rho means density of the liquid. G is the acceleration due to gravity. This formula only pressure exerted by the liquid. But even though, if you observe that, outside atmosphere also present, that atmosphere also will exert, will contribute some pressure on the bottom surface area. So finally, what is the conclusion we can take here? The pressure exerted on the bottom container is not only by the liquid, it is also pressure exerted by the atmosphere. Means the net pressure or total pressure, assume that as a P is equal to pressure exerted by the liquid plus pressure exerted by the atmosphere. If I pressure exerted by the atmosphere, if I take as a P naught, then total pressure is equal to P naught plus pressure exerted by the liquid. Pressure exerted by the liquid is H rho G. So actually pressure exerted by the liquid also known as gauge pressure. So here what is mean by gauge pressure? Gauge pressure is a pressure exerted by the liquid. It would be more than atmospheric pressure. Whatever the pressure having by the extra pressure having by more than atmosphere pressure is known as a gauge pressure. Here this is your formula, exact formula for pressure exerted on the bottom surface of the container due to the liquid. This is also called absolute pressure. In this formula, P is a absolute pressure, P naught is a atmospheric pressure, H rho G is a gauge pressure. Understand? So this is your formula. Understand? Now, one more question here, one more thing. Factors affecting the pressure exerted by the liquid. Factors depends factors affecting the pressure exerted by liquid. Factors affecting the pressure exerted by the liquid. So if you see the formula for pressure, if you observe the formula for pressure, pressure is equal to H rho G. Pressure is equal to what? Pressure is equal to height of the liquid, density of the liquid into acceleration due to gravity. So, by using the formula itself, we can say what are the factors will affect the pressure exerted by the liquid. Tell me, what is the first factor? The first factor is height or depth of a liquid will affect the pressure and pressure exerted by the liquid. Next one is, tell me, density of the liquid. Density of the liquid. Density of the liquid also affect the pressure. And the third one is acceleration due to gravity. Acceleration due to gravity also will affect the pressure exerted by the liquid. These are the three factors are affect the pressure exerted by the liquid. Got it? Now, based on this, we'll do some questions. Completed? Now we'll do some questions. Some examples questions. Now, first question. We have a lake or pond. The pond depth of the pond is 10 meters. Depth of the pond is 10 meters. When depth of the pond is 10 meters, and here, as usually in the pond you will have the water. Am I right? Yes or no? Yeah, water. The density of the water is 1000 kg per meter cube. The density of the water is what? 1000 kg per meter cube. Now, how much is the pressure exerted by this liquid on the surface of the pond, on the bottom surface of the pond? Find it. What is the formula we are supposed to use? Which formula is helping you to do this problem? Pressure is equal to H rho G. When you use this formula, pressure is equal to H rho G. Pressure exerted by the liquid is equal to height or depth of the liquid column. Here, if I take this as a reference, this 10 meters will consider as the depth, or if I take this as a reference, this 10 meters you should consider as height. Now I'm taking this as a reference. Now when I take this as a reference, this 10 meters is a depth. Then 10 into what is the density of the water? 1000 into what is the acceleration due to gravity value on the earth surface?
9.8.
I'll take 10. So finally 1, 2, 3, 4, 5. So which is 10 power 5. Units, tell me what is the units? What is the units here? Units are Newton per meter square or Pascal. So finally pressure is equal to how many pascals? 10 power 5 pascals. So this is your answer. Do it.
Yes, sir.
Now I'll give one more question. There is a container. There is a container. In this container liquid is having. So the container having liquid, the height of the liquid column is 5. Now here there is a liquid. The liquid you can take mercury. Here we have a mercury. In this mercury, the level of the mercury is 70 centimeter. The level of the liquid how much amma? 70 centimeter height, and it is what is the liquid is here? Mercury Hg. When it is a mercury, what is the pressure exerted by this mercury on the bottom surface area? So here density of the mercury is 3600 or 136 kg meter per 1360 kg meter cube is the density. Now I am asking to find what is the pressure exerted by this mercury on the bottom container of the bottom surface area. What is the formula here? The formula to find this question is pressure exerted by the liquid is equal to what? H rho G. Pressure is equal to H depth value is height or depth value is what? Liquid depth or height value. How much am I? 70 centimeter must convert it into meters. 70 into 10 power minus 2 meter. This is a height value. Understand? When the height value is 70 into 10 power minus 2, density value 1360 into G value is, you can take 10. So see this 10 and this 2 will get cancelled. Pressure is equal to 1360 into 7. So calculate and tell me the answer. Calculate and tell me the answer. How much? 9520 pascals. 9520 pascals is your answer.
Yes.
Understand? And next, suppose if atmospheric pressure also includes atmospheric pressure also increase here. Atmospheric pressure P naught you can take 10 power 5 pascals. When this atmospheric pressure also includes, then what is the pressure exerted by the liquid? What is the pressure exerted by the liquid? Tell me.
How much value atmospheric pressure?
Amma?
What's the value of the atmospheric pressure, sir?
10 power 5 pascals. Yeah. So tell me.
The answer will be 1,09,000.
Yeah, you can add total pressure is equal to pressure exerted by the atmospheric plus pressure exerted by the what? H rho g. Pressure exerted by the liquid H rho g. Understand? So, look at here, P is equal to, you can take here 1, 2, 3 and 4. So, which would be 1, 2, 3, 4, 0.09 into 10 power 5 pascals. You can take in that way. If I take in that way, then total pressure is equal to P naught value is 10 power 5 plus this total value is 0.09 into 10 power 5 pascal. So finally, total pressure acting on the bottom surface area, if I take 10 power 5 common, 1 plus 0.09 into 10 power 5. So pressure is equal to, tell me, 1.09 into 10 power 5 pascal is your answer. This is how the answers need to take. Okay? And the next, after this, shall I give one more? In the previous problem also, same atmospheric pressure is exerted. P naught value also 10 power 5. Then what is the total pressure? What is the total pressure in this case? Total pressure is equal to how much? Total pressure is equal to P naught plus H rho g. P naught value already mentioned how much value it is? 10 power 5 plus H rho g value is, what is the H rho g value? H rho g value also 10 power 5. Totally how many 10 power 5s? So 2 into 10 power 5 pascal is your answer. Understand? Now one more. As you see this types of, as you see factors affecting the pressure, what are the factors affecting the pressure? What are the factors affecting the pressure? Pressure is affecting by the height, density of the liquid and acceleration due to gravity. But observe this term, density of the liquid. So density will vary if you mix the two liquids, which means we have for example, we have a water. In that water, if you mix some other liquid, so that density of the liquid varies. In that case, how do you find the density of the mixture when you mix some other thing? Then what is the density? Some problems, let's see. Okay? Now let's see the problems. So write down density. Once again, I will talk about density. So what is this density? Tell me what is the value? mass per unit volume. Mass per unit volume will give as a density. Represent density rho is equal to mass per unit volume. Mass units are kg and volume units are meter cube. Volume units are meter cube. Totally, this is the formula for density. But here one more also there, relative density. Relative density. Here relative density means we are comparing one of the substance density with another one. This is known as a relative density. So the thing is, relative density is a perfect ratio between the two densities. So our relative density is a density. Relative density is a density. It is a ratio between. So better write on the form definition. It is a ratio between. It is a ratio between. It is a ratio between density of the substance. Density of the substance. There is a ratio between density of the substance to density of the substance to density of water at 4 degrees Celsius. It is a ratio between density of the substance to density of water at 4 degrees Celsius is known as a relative density. If I see the formula, relative density, I will take as a RD. RD is equal to, RD means not Rudramadevi, it is relative density. It is not Rudramadevi, it is a relative density. Relative density is equal to what? It is the ratio between density of the substance to density of the water at 4 degrees centigrade. Density of the substance you can take rho S, density of the water you can take rho W. So now density of the substance and density of the water having both are same units, they will cancel each other. So what is the final conclusion? The relative density is not having any units. The final conclusion is what? Relative density not having units. No units. For relative density, no units. Understand? Okay? Now, this is the density of the substance and density of relative density, the equations. In the coming classes, we will find a mixture density. How do you find mixture density? In the coming classes, I will explain. Understand? So, for now, I will stop the session. Bye.